Well, hi, hello, my dear students. Welcome to my video lecture class. Right, up to now I have uploaded a few video lectures on the topic horizontal projection. So today we are going to discuss some more details about this horizontal projection. So in this horizontal projection, we have a lot of applications. So, but I'll discuss a few important applications on this topic. Already I discussed in previous lectures most important applications, 6 applications I discussed. Those who are not watched the previous lectures, please go through YouTube and just go through the YouTube search box and type it horizontal projection by Sreesai Kema. You got all my videos. Well, so today we are going to discuss newer application. That new application is application number 7. So this is a very important application. This application also very useful for solving numericals in competitive exams like a JEE and a NEET. Right? If two bodies are projected in opposite directions from top of tower, projected. So here projection is horizontal projection. Okay, mentioned that. Horizontally projected. Okay. If two bodies are horizontally projected in opposite directions from the top of tower, right? So here I consider a tower. This is the tower. Tower has height is h. Right? So tower has height is h. So now this is the ground. This is the ground. This is the ground. So now one body projected like this. So another body is projected like this. Right. So here is one body. So that is projected like this. So this is another body. This is projected like this. Both are opposite direction projected. Okay. It is projected with initial velocity u1 meter per second. This is projected with velocity u2 meter per second. Both are projected horizontally. Okay. So now, first and foremost point is, if two bodies are projected in opposite direction from the top of tower of height h, one is moves with initial velocity u1 meter per second. Second one is moves with velocity u2 meter per second. So this is about given diagram. So now at what time velocity vectors are perpendicular to each other. At what time velocity vectors are perpendicular to each other? Two bodies projected now. So definitely after some time, so this body having some velocity that is moved in one direction. This body is having some velocity, it is moving in another direction. After some time, these two bodies' velocities are perpendicular. At what time these two velocity vectors are perpendicular? So this is P is equal to square root of u1 u2 by g. So this is very important. So here time is square root of 2t into u1 u2 by g. Right. So t into square root of u1 u2 by g. Sometimes question is asked like this. The time after at which velocity vectors are making an angle theta between them. Okay, sometimes question is asking like this. The time after at which velocity vectors are making an angle theta with each other. So like this are asking. So how can we apply formula here? Simple, don't panic, simple concept. T is equal to square root of 2 u1 by g. So let me observe one thing here. Generally time means u by g. Is it or not? But here we are taking two velocities now. So that's right. Square root of u1 u2 by g. Because we have to take in resultant velocity of those two. That's why square root of u1 u2 by g. So here t is equal to square root of u1 u2 by g into cot theta by 2. So this is the time after at which velocity vectors are making an angle theta between them. Okay, for example, so this is velocity vector, this is velocity vector, this is velocity vector, right? After some time, this is position of velocity vector is like this. After some time, position of velocity vector is like this. So these two are perpendicular or not? So these two are perpendicular at which angle? So perpendicular time at which time? So root of u1 u2 by g. So question is asked like this sometimes. The time after at which velocity vectors are making an angle theta between them. At that time you consider formula T is equal to square root of u1 u2 by g into cot theta by 2. Right. So this is about first one. Now, second one. The second one here. So already two we discussed. Third one. Okay. So already two we discussed. Third one. The time. Otherwise, what is distance of separation between them when velocity vectors making an angle theta between them. What is distance of separation between them when velocity vectors are making an angle theta, right? So this is the velocity vector, this is the velocity vector. So now what is the distance of separation between them? Okay, at that time what is the distance of separation between them? So let us consider the distance of separation is I consider as some capital D. So distance of separation between them D is equal to, distance means what ma? Velocity into time. Am I correct? Distance means velocity into time. Is it or not? So that means velocity into time. So here velocity means u1 plus u2, time means root u1 u2 by g. Is it or not? Root u1 u2 by g over. So already we know at which time velocity vectors are making an angle theta between them. Root u1 u2 by g into cot theta by 2. Cot theta by 2. Okay, if theta is 90 degrees, if angle between velocity vectors is 90 degrees, then distance of separation formula u1 plus u2, same formula. Here theta is 90 degrees, 90 by 2, substitute 90 by 2, we got 45 degrees. 45 degrees means cot 45 is 1, right? Cot 45 is 1 means you got here relation u1 plus u2 into root u1 u2 by g, because here theta is equal to 90 degrees. If you substitute theta is equal to 90 degrees, cot 90 by 2 means cot 45 value 1, tan 45 value 1, right? This is about the third point in this application. Okay, so next. Fourth point. The time after at which displacement vectors making an angle theta between them, so that formula P is equal to simple. So before that, the time after at which velocity vectors making an angle theta between them, you consider root u1 u2 by g into cot theta by 2. Is it or not? Root u1 u2 by g into cot theta by 2. Okay, root u1 u2 by g into cot theta by 2. Is it or not? So now for displacement vectors making an angle theta means just you take for displacement you multiply 2 before it. Just simple thing. Just multiply 2 here. So now displacement vectors making an angle. Velocity vectors making an angle theta between them means root u1 u2 by g into cot theta by 2. Displacement vectors making an angle theta between them means 2 into root u1 u2 by g into cot theta by 2. That's it. Next, fifth one. Distance of separation between two bodies when displacement vectors making an angle theta between them. Okay. Distance of separation. So what is formula? Distance of separation is capital D. Distance of separation is capital D. Then what we take here? Just distance is equal to velocity into time. So right. Velocity into time. Velocity means u1 plus u2. Time means already you know 2 into root u1 u2 by g into cot theta by 2. That's it. This is about this application, right? So sometimes asking when they are perpendicular, displacement vectors are perpendicular, displacement vectors are perpendicular like this asking in the question, so you must take theta is equal to 90 degrees. You must take theta is equal to 90 degrees. 90 means 90 by 2, 45. Cot 45 means 1. So simply we got 2 into root 1 into by g. So very simple yaar. Just you follow the lectures and make your notes. Just revise it. It is clearly understood. Okay. So this is all thing about today's session. Again we will meet on tomorrow with a newer concept and newer formula. This is your Sreesai Kema. I am uploading videos on YouTube. My channel name is Physics World. So please follow my lectures and like the videos and subscribe the channel. Thank you so much.